So today's notes, we're looking at measuring angles. We kind of talked about it briefly um, in class this morning, but just keep in mind on questions 15 and 17 on the assignment, the only thing I do 100% expect you to do for me on those two questions is to classify those angles. If you don't have a protractor at home, then you don't have to worry about measuring them. But if you do have a protractor, give it a shot, measure the angles, and that way you can verify. But on visual inspection, you should be able to classify them just fine. For the first part, we're going to do a review, just as always. So for question number 1, it says, ray AB names a ray with endpoints AB, and that obviously is true because I misread that because it says endpoints. So it does not have, a ray does not have multiple endpoints. A ray has a singular endpoint. It has the endpoint A. B is not one of the endpoints of that ray, so this is false. A ray only has one endpoint. Number 2, you name a ray by its endpoint and another point on the ray. That is true. So if we were talking about ray AB, look like this. That ray would extend through B and continue on infinitely in the other direction. Some of the words that we're going to look at today, angle obviously, because we're talking about measuring angles. Some word forms that you may encounter when we talk about angles is angular. You will encounter angular momentum in a physics class. We will discuss angular momentum when you guys have me for calculus. There's also angle and then angled. And then the angle is just formed by two rays that share an endpoint. And you can see that here in the examples below. For number 3, it says name the rays that form each angle. They both rays share the endpoint B. So our first ray we're going to call BA, and our second ray will be BC. On number 4, our first ray, we'll call it AB. And our second ray will be AC. Now, I do want to make sure that you guys are being cautious about your naming conventions and your notation. If it's a ray, it has to have that arrow pointing to the right above the letters. If it's a line, it will just have the arrows on both ends. And if it's a segment, it'll just be a straight line with no arrows on it. And then you also want to make sure, especially with rays, that your endpoint is the first letter listed. Some key concepts about an angle. An angle is formed by two rays with the same endpoint. We just covered that. The rays are the sides of the angle, and the endpoint is the vertex of the angle. You can name an angle by its vertex. So this diagram over here on the right, we could call it angle A. You can name a point on each ray and the vertex. So in this case, it would be angle BAC. And that vertex is always going to be the middle value or the middle letter in the naming convention. So we go from B to A, which is the vertex, and then to C. Or we could have angle CAB. But in both cases, that vertex is the middle value. And then the third way you can name an angle is by a number. And this one is labeled as number 1. So we can name it angle A, we can name it angle BAC, angle CAB, or simply just 1, angle 1. And we're going to use this angle, so I'm going to try to keep this on the same page if I can. We're going to, for 5 through 8, we're going to use the angle right here to name each part of the angle. So the vertex, we've already established, is A. 2 points that are not on the vertex are B and C. And then the sides are going to be those rays. The first ray is AB. The second ray is AC. And then 3 ways to name the angle. I've already done that in the previous portion. So we have angle A, if we name it by its vertex. We have angle BAC or angle CAB. And then we also have angle 1. So any one of those 4 names would apply to this particular angle. For problem number 1, we want to name or give other names for angle KML. So this angle is KML. That's what we're looking at right now. So the first thing we want to do is cross out a ray that is not part of KML. We know that the endpoint has to be M, so all three of these names are still possible. MK is definitely a ray on that angle. MJ is this ray right here, so that is not on that angle. And then ML is the other side of the angle. So the only ray that doesn't apply to this one is MJ. We're going to circle all possible names of angle KML. Angle 1 does not define KML because it's right here between MJ and MK. Angle 2 is a possibility. JKL violates the naming conventions completely because it goes from J to K and then down to L. So that is not a naming convention for that particular angle. And then we have JMK. So here's JMK. Again, that doesn't work. We have JML. That does not work. It includes our angle, but it's not the name of our specific angle. KMJ. That does not work for that angle. And then our final one is LMK. That one does work. So we have KML, LMK, angle 2, or we could also just call it angle M when we just name it by the vertex only. For number 11, we want to draw an example of each type of angle. An acute angle is always going to be between 0 and 90 degrees. And if I draw this angle right here, and maybe I label it, we'll say 25 degrees. That is an acute angle because it is less than 90 degrees. It's greater than 0 degrees. A right angle is always 90 degrees. And like I said this morning when I talked to you guys, this really all should be somewhat a review. So don't get too bored with it. We will build upon it. The third type of angle is an obtuse angle. And that angle is always between 0 or 90 and 180 degrees. So an example would be this right here, and we'll say this is 120 degrees. And then our last angle is a straight line, and it's always going to be equal to 180 degrees. And that's what we get with a straight line. For 12 through 15, we're going to use the diagram at the right to answer the questions. It says the measure of angle ABC is 70, so there's ABC. Measure of angle BFE is 90, so here's BFE. And then we want to describe each angle as acute, right, obtuse, or straight, and then give an angle measure to support our description. The first one that we're looking at is ABC. So from A to B to C, we see that is an acute angle, and it's 70 degrees. The next one is CBD. That is an obtuse angle. It's 110 degrees. And the way we calculate that to be 110 degrees is we know that this line is 180 degrees. This angle is 70. So the remaining angle has to be 180 minus 70, which would be 110. Our next angle that we want to look at is angle CFG. We have CFG. That one is going to be a right angle. So it is 90 degrees, and we know that again because this line this line itself is 180 degrees. This angle is 90. This angle has to be 180 minus 90. So that makes it 90 degrees. And our last angle is CFH, and that's going to be straight angle, 180 degrees because it's a straight line. All right, so measuring and classifying angles. What are the measures of angle LKH? So let's first highlight LKH. We go from L, K is our vertex, and then over here to H. So that angle is indicated. It goes from 0 up to this point on the protractor, which would be 35 degrees. And if it's 35 degrees, that's less than 90, so that makes it an acute angle. Our next one is HKN. So we go from H to K to N. That's a straight line, so it's 180 degrees, so that is straight. And then our final angle is MKH. So we go from M to K to H. And that's going to be indicated by this angle. Start at 0 and we go around to 145 degrees on the protractor. Obtuse. Because it's greater than 90 degrees but less than 180. Almost made it through a set of notes without some crazy Zoom thing happening, and it happened twice in a row now. All right. Oh my gosh. Doing it. All right. Using the photo at the right, if the measure of ABC is 49, so here is ABC, that's 49 degrees. What is the measure of DEF? So ABC has one angle mark. That is this little angle mark right here. So it has one angle mark. The other angle with the same number of angle marks is angle DEF. Okay, so when we see angles that are indicated, if they by a notational symbol such as this angle mark, if there's multiple angles that have one angle mark, it means they are congruent. If we have multiple angles that have two angle marks, it means those angles are congruent to one another. They're not congruent to angles with only one angle mark. And you can see examples of two angle marks down here in this lady's armpits. She has two angle marks under each armpit. Underline the correct word to complete the sentence. The measure of angle ABC and the measure of the angle in exercise 18, so that's angle DEF, they are equal because of the congruency indicator with that single angle mark. And so if the measure of angle ABC is 49 degrees, then the measure of angle DEF is also 49 degrees. The angle addition postulate. So this goes back to questions 11 through 15, where I did the subtraction from 180 and came up with the angle measure, even though it wasn't expressly given to us. With the angle addition postulate, if point B is in the interior of angle AOC, then the measure of angle AOB and the measure of BOC is equal to the measure of AOC. So the first thing we want to do is draw angle ABT with some point L on the interior. I'm going to draw this ray, and I'm going to put this point L. And I'm going to label this one A. I'll label my vertex B because that's how it was given to us, as the vertex being B, and this is T. So now we have two angles. We have angle ABL and we have angle LBT, and then we want to complete the addition postulate. So the measure of angle ABL plus the measure of angle LBT is going to be equal to the measure of angle ABT. All right, so if I add this angle ABL, this angle LBT, they're going to sum up to the total angle of ABT. So those two interior angles add up to make angle ABT. Question number 4, or problem number 4, using the angle addition postulate, we want to go through the steps. We want to justify each step in the process to complete this problem. If angle DEF is a straight angle, so we know that's 180 degrees. So I'm just going to write that on here just for notation. What are the measures of angle DEC and angle CEF? DEC is given by the equation or the expression 11x minus 12, and then angle CEF is given by the expression 2x plus 10. Measure of angle DEF is 180 degrees. Write it again because it's already written right here. But we want to justify why that statement is true, and it's just because it's given as a straight angle. So a straight angle is equal to 180 degrees. The measure of angle DEC plus the measure of angle CEF is equal to 180 degrees. That is the angle addition postulate. Then we have 11x minus 12 plus 2x plus 10 is equal to 180. We've just substituted in the expressions that were given in the diagram for their respective angles in the previous step. And then when we simplify this, we end up with 13x minus 2 is equal to 180. Fine. We're going to add 2 to both sides, and that gives us the 13x equals 182. And then divide by 13. And that's where we get x is equal to 14. So if we substitute 14 in for the measure of angle DEC, remember it is initially it's 11x minus 12. Now it's going to be 11 times 14 minus 12. And when we multiply 11 times 14, it's 154. 154 minus 12 is 142. So the measure of angle DEC is 142 degrees. The measure of angle CEF, it starts out, we're given 2x plus 10. We're going to replace x with 14. 2 times 14 is 28. 28 plus 10 is 38. Right percent, sorry. So 142 plus 38 is 180 degrees. That's just a verification that we did come up with the correct straight line. And our last thing is the lesson check. We're going to apply a little bit of algebra. If the measure of angle ABD, so this whole angle right here is 85 degrees, what is an expression to represent the measure of angle ABC? All right, so we're trying to find, I shouldn't use blue again, let's use red. We're trying to find an expression to measure angle ABC. First of all, we have that ABC plus CBD is equal to ABD. That's from the angle addition postulate. We're adding those two interior angles. Measure of angle ABC plus X is equal to 85. We're given that ABD is 85, so we're just substituting that in. We're also shown on the diagram that CBD is X. If I subtract X from each side, get 85 minus X. So my X's right here will end up canceling one another, and all I'm going to be left with on the left is the measure of angle ABC, and that will be equal to 85 minus X. So that's the review, hopefully, of measuring angles. If you all have questions, please feel free to ask. Remember, your assignment is not due until Monday night, so don't submit it unless you're 100% positive. I don't want to see any more submissions where you say, well, I'm turning this in, but I didn't know how to do number 7. You still have a couple of days to work on this, so make sure you know how to do it. You're not going to bother me if you ask me questions. I hope everybody has a wonderful weekend again, and I'll be talking to you on Monday.